Hi everyone. Let's look at working with functions where you add and subtract and multiply and divide functions. I don't think this concept is too difficult to understand, but I just need to make sure you guys are cool on the lingo here. So if you have, if f of x is x plus 3 and g of x is 3x minus 1, first of all, let's find f plus g of x. Okay, now hopefully you're picking up on this, that f plus g, you're adding the two functions together. Okay, so all you're doing is just taking x plus 3 plus the 3x minus 1. And you can work without the parentheses in this case because you're adding x plus 3x, that's 4x. 3 plus a negative 1, that's plus 2. And there you go. As for subtraction, f minus g of x, this one you got to be a little bit careful on. We'll go x plus 3 minus the quantity of 3x minus 1. So just be careful here that you got to distribute this negative sign through. So it'll be x plus 3 minus the 3x plus the 1. Okay, be real careful there. A lot of people miss that sign. Okay, so you're distributing the negative sign through in two locations in this binomial. And when you simplify this, now we're looking at negative 2x plus 4. Multiplication, you're multiplying two binomials together. F times g of x, that's going to be x plus 3 times 3x minus 1. So I'll take x times 3x, that's 3x squared. X times a negative 1, that's a negative 1x. 3 times 3x, that's 9x. 3 times a negative 1, that's a negative 3. Combined like terms, we're looking at 3x squared plus 8x minus 3. Done. And then finally division. Believe it or not, in this problem, that's going to be the easiest one of all. That's just x plus 3 over 3x minus 1. I don't have any factors that will reduce. Right? You don't want to try to reduce this x with this 3x because I've got addition and subtraction happening in the numerator and denominator. The only way I would have been able to divide out this x with this x is if this x in the numerator is getting multiplied to this 3, or if this 3x is getting multiplied to the negative 1. That's not the case, so that problem's done, and so is this video.